My name is John Posada, and today we're going to be talking about the database migration agent. So what we want to focus on today is how we can migrate from Oracle to Postgres and how that can be one of the most complex and time-consuming tasks in database modernization. Today, I'm going to show you how our AI-powered migration system transforms this process using a 6-agent architecture with human-in-the-loop quality control. The system uses 6 specialized AI agents working together in a pipeline. Each agent has a specific job. We have extraction, conversion, syntax validation, performance validation, remediation, and then deployment. So let me show you how this works in practice by actually showing you the architectural design. So here's how the agents work together. First, you have the extraction agent, which reads the Oracle DDLs from your source, whether that's a file, a Git repository, or a live Oracle database connection. Next, we have the conversion agent. This uses Google's Gemini 3 Pro model in the backend to transform Oracle syntax into PostgreSQL. This isn't just a pattern of matching. This is the GenAI model understanding the semantic meaning of your database's actual schemas. Then the syntax validation agent checks the converted DDL against a real PostgreSQL database using a package called plpgsql_check in Python. This actually catches actual syntax errors and not just theoretical ones. And it also produces a score. From there, we're going to go next to the performance validation agent, which scores the quality of the conversions on factors like completeness, correctness, and data type accuracy, as well as computational speed. When we have these both agents complete, they score a value that says syntax 40 plus performance 60, that means that we're taking 40% of the syntax total score between 0 and 100. 60% of the performance validations agent score from 0 to 100, and we're going to combine them to create a new threshold value, which in this case should hopefully be above 85%. If it's not above the 85%, then we're going to actually go ahead and introduce a step where we have a remediation agent incorporate human feedback, which is what we call human in the loop, and retry the conversion up to 3 times. So what this means is when we add these two scores together, if they're 85 or below, we're going to go through a process where we have a UI with a human in the loop, where we're going to actually review the feedback that was given to us based on these two agents' outputs of the actual conversion. And we're going to go ahead and submit them for remediation. And that process will take place up to 3 times. If it happens that the score is above 85%, that will go to the deployment agent, which will then send it to the target source, which in this case is Postgres. If we fail more than 3 times, then that means that now that's been logged in the system and we need to go ahead and review those actual conversions manually ourselves. So let's start with a straightforward conversion. I'm going to run a schema which has simple tables and sequences. For me to do that, I'm going to go ahead and go to my command line interface, as you see here. So you should see here in my command line interface that I have a command that has been written out. It's uv space run space db migrate space workflow run Oracle DDLs, and then the actual name of the DDL itself. In this case, it's just easy1 library. And then we have flags. We have 2 flags here that you'll see. It says --no--auto--approve, and then --UI. What this means is that when we're reviewing DDLs, we actually don't want them to be auto-approved if they're above that 85%. What that means is that we want to actually review them inside the human in the loop process. If you were to remove this flag, then that means that the agents themselves will review the output that comes out from both the syntax and validation agent. And if the value for the threshold is above 85%, those DDLs will automatically be deployed to the Postgres database. If they're not, then because we have the no auto approve tag set up in place, we'll be able to actually review what that content looks like inside of the UI. And then because we added the --UI, that means we actually get to see this happen live itself inside of the actual UI when the agents are processing that information. Great. So I'm going to go ahead and start this up. I'm going to press enter. And then what's going to happen is you're going to see now that the migration has started. So you'll see some logs that's talking about the migration workflow. And then you'll see here what's running. In this case, you can see some of the agents themselves that are actually running and the content that relates back to them. So when you're doing this, make sure you watch the terminal because you can see the agents run. You'll see that the extraction agent is already reading the Oracle DDL. And now the conversion agent is going to then go ahead and transform it into PostgreSQL. And that's where the syntax validation agent is going to come in and check against our PostgreSQL instance. And the performance agent is going to be scoring that result. So we're going to wait momentarily here. So you can see here, we already got the conversion agent that's called upon the Gemini API. In this case, again, we're calling upon Gemini 3 Pro. We could use different Gemini models. We could use the 2.5 Pro or the 2.5 Flash, or we can also use the Gemini 3 Flash as well. So, okay, we've seen here that the conversion was successful. We've got the orchestration taking place now, where we have the syntax validation actually reviewing specifically that conversion. So I'm going to hover to my right. And now let's look at the web interface. So I'm going to go ahead and refresh the page. You'll see here that we have one pending review. And you can see here that we have actually a schema that's being reviewed right now by our agents. And you see here, we'll see a score that says 0%. That's okay. That's normal. That just means that it's about to be scored. At some point, we're going to see this populate. And that's going to give us a value of between 0 to 100. That takes in consideration both the validation and the syntax agent's actual output. I'm going to refresh that page for 1 second. In the meantime, I'm going to go back to the terminal so we can see where we're at. We're still here initializing the validation agent with the model. We're using, in this case, Gemini 2.5 Flash, as you see here. So I'm going to go back to the UI. I'm going to refresh. We'll see here that we still have 0.0%. That's fine. This should now populate with information once we have the conversion quality agent complete. We'll give that a couple minutes. There we go. It's approved and it completed. So let's refresh. And we'll see now we have 100%. So in this case, this actual DDL has 100% based on the scores that came back from the syntax validation agent and the performance agent. So in this case, we can go ahead and click review. And we'll see here we have some information that I want to talk to you about. So here's a side-by-side comparison. You're going to see the original DDL, and then you're going to see here on the right the converted PostgreSQL. You can see also that, once we've converted the DDL to Postgres, we have some context here that we're sharing about what was the immediate conversions, what were the scores that we received, any issues that we found, or any recommendations specifically that stand out. So basically, what we're seeing is that the validation breakdown shows exactly how the score was calculated, as you see there, and what are the scores for each one of those categories. And then also detailed assessments, any recommendations that come from that. And then in this case right below, we'll see all the SQL code that has been written. So even though the quality is high, we still require human in the loop as approval because we selected the option that states no-auto-approve. So now on the bottom, you see here, there's an option that says approve and deploy. I can go ahead and click on that, which I will. Now, once I've done that, then you'll see here that now that DDL no longer appears in the window, and instead you can see one DDL that's been approved, one that's been converted. That's basically 1 for 1, and we have an approval rate of 100%. So now I'm going to go back to the terminal. And we can see here that, we've completed, the workflow was paused. We can go ahead and type the command to resume. In this case, we don't have to do that because that was already done for us automatically inside of the UI. So now that we've completed this, and we've shown you how one DDL is actually converted, the next step is I want to show you how we can convert multiple DDLs in parallel with the remediation agent if necessary. So I'm going to go ahead and stop the CLI right now. That's been complete. I'm going to go then now to the next CLI that I have here available, which actually already has the command that we need specifically for the parallelization. And I'm going to discuss to you exactly what are we seeing in these commands and what do they actually mean. So let's start off by talking about what this actually is going to do for us and what these commands actually mean. You'll see here that we have different commands for multiple files. So first, we're going to see that we have the DB migrate and workflow like we had before. We have a new command called run-batch. That's going to allow us to run in parallel the actual DDLs that we want to convert. We'll see here that we have Oracle DDLs. And then we have a couple flags. We have dash parallel. This means that we're going to process 6 DDLs in parallel since we have the number 6. We have no dash or auto dash approve, and then we have the UI option because we want to see the UI and we want to make sure that these DDLs are not automatically approved. So I'm going to just go ahead and click enter. And then you'll see here that we've started to launch the UI server itself. We've also see here that we've actually started to work on those 6 DDLs specifically. So a little bit difference that we're going to see here is unlike when we're processing one DDL at a time, when we're processing DDLs in parallel, we won't see that whole log setup of all the commands that the agents are following and what they've completed or whatnot. Instead, we're just going to go right back to the UI itself and we're going to refresh it. And then we'll wait here momentarily. At some point within less than a minute or so, we're going to start seeing all those DDLs start to populate inside of our UI for us. So we're just going to give that a few minutes and then I'm going to come right back to you once it starts to populate. Okay, we're back. It's been a little bit less than a minute that's passed as time. And now what we can see here is we've already seen 3 of those DDLs actually get populated. And we can see here that we've already got some scores for 2 out of the 3. So we can see here we have one for 98.8%, one for 100%. We're gonna look at the 100%. Again, Oracle DDL, the original. Then we have its converted output for the SQL schema itself. If we go here below, we'll see here where it says request remediation. We can see here that we have some issues to address if need be and if necessary. And then we have some recommendations given to us. This is coming back from both the syntax agent and then also the performance agent so that we can go ahead and address if necessary. If we want to, for the issues to address, we just select both options that we see available here, like redundant SQL calls, implicit column lists. And then for the recommendations, we can look at modernizing identity columns, refining cleanup logic, specify columns and inserts, and just click submit remediation requests. And that will allow us to go back and resubmit this DDL. But in this case, because we got 100%, we don't actually have to go do any form of remediation. We can just click approve and deploy, and that's going to get deployed now to that server environment for Postgres. We see here we have a few more. We have 3. We're going to just go ahead and review them and approve them as well. We have one here that scored 55.2. So we're going to go ahead and select that option, and we're going to see why. So if we scroll down, we go to request remediations. We can see here, okay, we have a few items to address: missing sequences, potential partition omission, package object cleanup. Those are concerns that we need to address because these are issues that need to be addressed. We also have some recommendations, so we're going to select those as well. And then we also have a location for additional feedback for the conversion agent. So if necessary, we can go ahead and provide feedback so that way that the agent is able to go ahead and inject that into its prompt dynamically. These are situations where we have edge cases like the way you're seeing here, we're able to actually make some modifications to the prompt so it can catch that when it does the conversion once more again, at least until it gets to the max or limit of 3. So I'm gonna click submit remediation requests, and then we're gonna go ahead and approve the other 3 DDLs. And there we go. This is the last one. And then now we're going to wait for that one to come back that scored around 55%. So we're going to give like another minute or so, but you can see here above, we have 0 pending reviews for now, 5 have been approved, 6 that are total conversions, and that we have in total to convert. And then we have an approve rate of 83.3% because we've only approved 5 out of the 6. So we'll give that another minute and then we'll come right back to this. All right, let's check the results. So we can see here that the quality has improved. The system basically learned from the feedback that we had selected and sent back to the remediation agent. The partition syntax is also now correct and the package functions have been properly refactored. So we can click on review just in case. Let's look at the request remediation. And we can see here we still have some recommendations, but the question is whether or not the threshold that we have now is sufficient for us to move forward. If not, we can go ahead and adjust these and send them back again for the remediation request. In this case, I'm just going to go ahead and click approve and deploy. And now we can go ahead and approve this conversion with confidence. And that's it. It's deployed. We've successfully converted a complex Oracle schema that initially showed lower quality checks. So now let's recap what we've seen. So what we've seen is that Oracle DDLs go in, the 6 specialized agents process it in sequence. A quality threshold then determines whether human review is needed. Humans can then provide feedback to improve conversions, and validated SQL DDL comes right back out, which gives us our target database output. As a side note, the source database and also the target database are customizable. Because the system is modular at the agent level, we can create modular interfaces and connectors for different databases, making implementation agnostic with respect to database source and or target. The key differentiator here are, first, we have specialized agents for each task instead of one monolithic system. Second, an 85% quality threshold is an automated gate. Third, a human-in-the-loop review with feedback capture, and fourth, a learning remediation loop that improves based on your input. And fifth, and lastly, real Postgres validation and not just pattern matching. So as you can see, the output then gets delivered cleanly into an organized Postgres DDL files that are ready for deployment to your target database. And that will be basically the output location path that we have available. And that's it. That's basically the database migration agent. It's an AI-powered Oracle to Postgres conversion with the quality controls for your enterprise's demands.